Hello everyone and welcome back to my channel. So today we are going to talk about a wonderful project where we are going to deploy a three-tier architecture based application on an EKS, that is Elastic Kubernetes Service. So basically in this video we are not just going to deploy things, we are also going to understand how things work on production. So in general, what we used to do is like we used to write a pipeline so that we could deploy the application using kubectl apply, or we also were directly trying to access the application using load balancer DNS, right? But in this particular video, we are going to go one step ahead by using a domain. So we are going to host our application on that specific domain with the help of um, this particular Route 53. Okay, we are also going to implement SSL in this. Okay, we are also going to implement Ingress, right? Which is again very much important, right? So in production systems, it's generally used and it has got its own significance, right? So there are multiple things which Ingress can provide you, which are not possible just with the help of load balancer, right? So we are going to understand them one by one, okay, in this particular project. So basically, let's try to understand the high level overview of how things are going to be deployed on an EKS. Okay, so basically, we have got three different tiers over here, that is front end, back end, as well as database. And what we are going to forward using Ingress is that whenever there is a request for on this particular domain, if it hits slash path like vanderblock.online slash, it should go to the front end service. That is how we are going to design our ingress. Then if it hits slash API, it should go to the backend service. Okay. So we are not going to access our database directly. Also, it is not advised to access the database via your website. Okay. It should be accessible through the backend service, but not directly, right? So for that matter, we are not adding that rule for our ingress over here, right? So we are not going to access the database directly through our ingress. So we have got front-end service, which will be exposing our front-end deployment. So basically front-end as well as back-end are stateless applications. So you don't need to store the data in this case, right? It consists of the logic. So we just want to make use of the logic over here, right? Like if example, if one of the pods of this front end goes down, the other pod is there, and if and deployment will take care that it has got two replicas running. So if one of them goes down, it is going to create another one, right? Which will be serving the traffic. So there's no issue, and we don't need to store any data in this particular case, right? So we are not making use of stateful sets over here. So in these two cases, we are just simply implementing deployment over here and maintaining two replicas for each of them. Then we have got MongoDB over here. So MongoDB service is exposing your stateful sets. And this service is basically the headless service. Okay. So we are going to understand what is a headless service also. These two services will be cluster IP services. Okay. So you don't need to expose or create a load balancer service over here because it will be taken care by the AWS ALB controller. So basically, for implementing an ingress, you require an ingress controller, right? So for that, we have this AWS ALB controller, which will be creating a load balancer for us. Okay, so you don't need a separate load balancer service for that, right? So it will be handling the incoming traffic for you, and Ingress will be routing based on the paths. That is, the path-based routing will be implemented using Ingress. Okay, and then we have this MongoDB service which will be pointing to our stateful sets. Okay, and in this case, why are we making use of stateful sets? Because MongoDB will be our stateful application, right? Here data is very much important. For example, let's consider this Mongo 0 goes down. It should create Mongo 01 itself. Why? Because it is connected to PVC, which has got the data that is required for this particular pod to run, right? So that's why data is important in this particular tier, right? So for that matter, we have made use of stateful sets over here. Okay, and then we will be creating PVC, that is persistent volume claims, for each of these pods over here, right? And these will be claimed from our storage class, right? As well as the persistent volume. So this is about an overall high level overview. Okay, so this is what we are going to implement here, and I would suggest that you can also add this project on your resume. It is going to increase your value very much, and also you'll learn so many things in this particular project. Okay, so now let's try to understand how to write the manifest files for all of these resources for our EKS. Okay, so before actually writing these resources, we are going to also understand how to set up the EKS cluster. So basically, there are two ways through which there are multiple ways, in fact, through which you can create an EKS. So in this particular video, I am going to make use of EKS-CTL. Okay. So for that, I have written a specific config file for it. Okay. So in here, you can see I have defined the API version. Then the kind is cluster config. Okay. And I have mentioned the version along with the region, the name. All of the metadata has been mentioned over here along with the tags. Okay. Then you have got the availability zone within which your worker node should span. So basically, I am going to ask for two nodes. So both of them will be created in each one of them, right? Then with I am with OIDC equals to true, right? So this is basically for the OIDC connect. So I want my IAM should be integrated with the EKS cluster. Then comes is and this is basically used with the service account. So if you want to implement IRSA, that is IAM role service account, then in that case, this has to be true. Okay. Then for the managed node groups, I have given this name, that is Vanderblog node group, and the instance type is medium. The minimum size is 2, maximum size is 2, and then you have private networking. Okay, so that is what we want it to be in a private network, and the volume size is 20 for these nodes, right? Then I have got IAM definition. So policies should be given and which should not be given are defined over here. You can also add this to be true. Okay, so let me do that for now. Because I'm going to implement EBS CSI. Okay, so I'll make it true. I'll also add the labels for it, basically for the EC2 autoscaler. This is not very much required, but in this particular project, we are not going to implement any autoscalers, but just for time being, I have mentioned it. you can ignore it as well. Okay. Now the next important thing is that let's try to understand how have we written the manifest files. So basically, the application contains three tiers, that is front end, back end, as well as database. So the front end is being defined or configured under this folder, that is front end. It is basically written in React. Okay. Then we have got the backend. So for the backend, we have used the server folder and it is written in the Node.js. Okay. Then, yeah, and for the database, that is MongoDB, we are going to directly use the pre-built, already existing image of MongoDB. So we don't need to define it anywhere. Okay. We are directly going to call it inside our stateful set. So now over here, these are my Kubernetes manifests. I have simply written manifest. I haven't made use of any package manager like Helm, configuration management tool like Customize. Basically, in case of Customize, you generally use it when you are deploying your application on a kind of different environments and they have got minor differences between them. So instead of rewriting all of these files for the different environments with just minor differences, you just customize them using your customize tool, that is the configuration management. So basically that is one thing. Since we are just using a single environment, I'm not going with customize. Also, I didn't want to make it more complex. Okay. So I didn't implement Helm as well, but you can definitely try it out. And if you want me to create one separate video on Helm, I will be happy to create a separate video. If you want it, please let me know in the comment section. I'll be there to create one. Okay. So let's try to understand what have I written over here. So the most important thing is that for each of the tiers, I have written three different files. Basically, the one that is front-end deployment, front-end service, as well as front-end config. So let's try to understand one by one. So basically, if I go inside this front-end.yaml, you can see that this it is a basic template. So if you have already watched my video of replication controller versus replica sets versus the deployment, then you might understand this template very well. Okay. So if you want, you can just go through that video first and then you can come here. I can add it in the description as well. Okay. So these things are very much common. So this is the API version used to create the deployment. The kind again is deployment. Then the metadata is where you define the names and the labels. And within the spec, you define the replicas, the selector. Okay. And this template part is where you actually define the configuration for your pod. Okay. So what happens is if you see the template part, this part, within this you can see the metadata as labels where I have defined app is equal to front end. So this is the label that is being given to your pod. Okay. So this deployment, okay, what it does is it selects based on this particular label itself. So if this labels match, then that particular pod is managed by the deployment. Okay. And it will create two different replicas of it. Okay. So this is how the selector works within the deployment. Now, within the spec, you can see this part. Now, this is something that most of you might have not um never seen, right? So basically, this is for the topology. Now, what is this topology? Now, let's try to understand this, okay? So let's consider this is my EKS cluster, okay? Within this EKS cluster, I have got two different nodes, right? Since I have defined it that way, right? Within the EKS config file, I have defined the mean size to be 2 and max size also to be 2, right? So, and each one of them is in the different availability zone. So this is AP South 1B, right? Since I am deploying my EKS or configuring it in the AP South 1A, and I have defined these two availability zones, and this is the requirement of having two nodes. That is why this would be the scenario. Each availability zone is going to have a single node, right? That is a worker node. Now, if I define the deployment where replicas are two, there are two possibilities, right? One possibility is that both of these nodes, sorry, pods of this particular deployment, both of them are scheduled on a single node. This is a possibility, right? So it is good. There is no problem in that. But the problem arises when there is a outage. What happens if this availability zone goes down? Then my entire application goes down because both of these pods of my front end are deployed or scheduled on a single node, and that zone is now down. Now, how will I be able to access this? It's not possible. So, in order to provide high availability, what am I doing is I am asking the pods to be scheduled in such a way that if they are on the same availability zone, they should not schedule on that particular node, right? So this is the meaning of it. So affinity is what I have defined here. So pod affinity, that is the pod should repel each other if they have the same labels on them, okay? And the topology key is like they should repel on the basis of the zone, right? So they are defined, so they are considering these two factors. That is, if they have got the same label as well as the topology key, they should repel each other. They should not schedule in that case. Understood? So this is something that was um, very important for you to understand. So I hope this was very much clear to all of you. And then we have got this containers, right? So here we actually define our image as well as the container port on which our application should be running, right? Within the, or our pod should be running, right? So this is where I have defined it. Okay. Then we have got environment from config map reference. Now this is important. So over here you can see that I have passed the reference to the config map, right? Let me open it in another tab. So this is the config map that I have defined. Now, what have I defined over here is the API URL. Okay. Now, this is the API URL, that is slash API. Why is it slash API and not the backend service directly? Because we are implementing Ingress over here, right? So, if you see this, our Ingress is pointing to the backend service, right? And Ingress works at layer 7, whereas backend service is going to work at layer 4, that is the network layer, right? So it is pointing out here. But when you are executing your front end application, it is going to run on a browser. And browser is something that works at layer 7, right? So it does not understand if you pass backend service there. Here, if you pass backend service, it won't understand because backend service is only limited to your cluster, right? Whereas this slash API is exposed by the load balancer via Ingress, right? So this becomes accessible only via this thing to the browser. Okay. So for that matter, we have defined the API URL as slash API over here. Okay. And how will this connect? Let's try to understand. For that, you need to go inside your front end. Okay. So if I go inside my front end and go inside the source within the app.js, you can see over here the API has been passed from here. So you are passing this, right? This is nothing but my API URL. Now this API URL is required because in order to allow your front end to talk to your backend, you need this connection. You need the API URL, right? So for that matter, you need to define the URL over here. But you don't have the URL, exact URL, right? So what you do is you define that env config.js over here. So what it will do is if you are passing any environment variable that is API URL container, it will just take that, okay, and pass it over here and then eventually to your application that is running inside your container. Okay, so basically what happens is within the entry point. Now let's go stepwise. Okay, now you understood. So let's be clear what happens. Now this is your entry point dot sh, right? This is your entry point and this is within your container. Front end container, right? So this is your front end container. Now on top of this is your front end pod. Simple. Now what you are doing in this case is you are providing the environment of your front end config. Now if I go to my front end config, I am passing this value, right? So my pod gets this value, right? My pod has got this environment variable API URL is equal to this thing. Now the same thing is available to this particular container as well. That is your entry point.sh. Now what does entry point.sh do? It will replace. Let's go to my entry point.sh. Over here, if you observe, it is going to replace the value of this $API URL from your env config.js with the actual value that is being passed. So this is going to go to your env config.js, right? So now within your application also, the API URL is now set to /API. Okay. Now, when we execute the container or the pod is up and running and we access it, right? So it the browser will be able to identify the /API, which is being defined by my ingress. So you need to understand all of this before actually writing your manifest files. So if you want to implement Ingress, you will have to identify all of these things. Okay, so it is very much important to understand it. So I hope why have we used this front-end config is very much clear to all of you. Okay, now this was all about your pod. Now I want it to be exposed, right? See, pods are very ephemeral in nature, right? That is, if one pod goes down and comes back again, it doesn't come with the same IP address. Let's say initial IP was A.B.C.D and then it goes down. When it when the deployment, right, what will deployment do? Deployment will then create another pod, but this time the IP will be x dot y dot z dot, let's say, a. Okay, so the IP address will be different, right? So they are not consistent enough. So for that we make use of a service, right? So on top of this we need a service for our front end. So this front end service will take care of being there irrespective of whatever the pod IP is. This IP will stay the same, right? So that is the reason we make use of services. And in this case, we will be going to keep it as cluster IP because we don't need the service to be load balanced itself, because that will be done by some other controller for us. Okay, so I will be keeping the type of this particular service as cluster IP. Okay, so this was all about my front end. So I hope it was clear. So what have we defined over here? We have defined the deployment, we have defined the topology, we have defined the image as well as the port on which our container should run. I have also defined the environment variables with the help of frontend config.yaml, and at the same time I have also defined the service over here which you can see. Okay, I hope it was very much clear. We can also understand the Docker file over here. So basically the Docker file that I have written over here is a multi-staged file. So over here you can see that this is my base image, okay, and that is the Node 20 Alpine. For the build stage, I have used this particular base image. Then this is the working directory, and this is the actually stage where I am actually building my application. right? And then using this particular image of Nginx, I am trying to copy the files from the build onto this particular location, okay, where it will be uh, copying all of the required files for the application to run. And similarly, I have also passed the entry point.sh for passing the API URL from the config, from the container level, right? From the pod level to the container level, right? So for passing that environment variable, I have generally made use of this particular file. Then we are trying to make it executable, right? And then we expose it. This is the entry point and this is the CMD. Okay. So this is how we have defined our multi-stage file so that the size of the image will be very less as compared to the original one. If I just use a single stage file, the size will be very much large. So in order to reduce the size and at the same time to make it very much efficient, I have made use of a multi-stage file, Docker file over here. Okay. So I hope it's very much clear to all of you regarding the front end. Now, similarly, I have also defined for the back end as well, right? So over here you can see these are the 4 files related to backend. Okay. So over here again we have defined the deployment for the backend, right? The replicas again the same selector. Okay. Then we have implemented the template. Again for the topology, we have defined it for the backend as well. Then over here you can see that the container port is 5000. Okay. And over here we have passed 2 different things now. First thing is about the backend config. Again, we have passed the config file, right? Now this config file has got the port. Okay, since the application was designed in such a way that it required port to be passed, right? So for that matter, we have defined this over here. Okay, and the next thing is about the secrets. So this secret is basically for the Mongo URI, right? So basically, if you don't know, let me open this code once again. Okay. Within the image, I have defined few things, right? In the repo itself, I have. Yeah. So if you see this Mongo, not this one. Yeah. If you see the Mongo URI over here, you can see that it contains username, password, right? The service on which your MongoDB is running and the port, right? So all of these details can't be exposed, right? So they need to be secretly stored, right? And since over here we are making use of GitOps, we can't directly mention this in the GitHub because it will be vulnerable. We can't directly store our secrets. See, this is a what I am doing is temporary stuff, right? It's not a production level, right? But in case of real world scenarios, these passwords are very critical. It is important to not leak these passwords, right? So for that matter, what we need to do is we need to store these secrets in a sealed form. So for that matter, what we do is we make use of sealed files. So first of all, all of you might say that you can create a secret.yaml file and save it in that, right? Absolutely, you guys are brilliant. But the problem with this is that it is base 64 coded. Okay, so the problem with a secret file is that this particular secret, if I say there is a token, this is stored in the form of base 64 coding, and this can be easily decoded. Okay, so we don't want this to be that predictable, right? So in order to use a next level of encryption, we make use of sealed secrets over here. Okay, so for that we have installed the sealed controller as well, secrets controller. So with the help of Helm, what we do is we install these controller and we use it for our application. Okay, so we will be executing these commands. So we are passing the actual Mongo URI over here, right? But over here you can see the encrypted form, right? So this is how it is getting stored on your GitHub. It won't leak your secrets that easily. It is not something that is a base 64 that can be easily decoded, right? Decrypted, which we don't want that to happen. So we make use of seal secrets. You can use multiple tools or different ways of storing your secrets, but this is one such way through which I have implemented it. Okay, we will also see this in the demo part. Okay, where we will be executing these commands, on our EKS cluster, right? Because these require the controllers. So these are the controllers basically. Seal secrets controller. So this is the controller responsible for sealing your secrets so that they won't leak that easily. So that for that matter, we are going to execute these commands and create these seal secret files and then store it on our GitHub, right? So this is going to be our process. Okay. So this was about your seal secrets for your backend. Okay. So this is the Mongo URI that we are passing. Okay. And since the Mongo URI is something that is not accessible, if you look carefully over here, we haven't forwarded any path-based routing to this MongoDB service. Why? Because we don't want these MongoDB service to be accessed via the load balancer. We don't want this. We want only the backend service should be able to talk to our MongoDB. And for that matter, we have passed the Mongo service over here and it is at the cluster level itself, right? So at the cluster level, Mongo service will be accessible. But at the browser level, it won't be accessible, right? And that is what we want, right? So this is how we have defined the backend deployment, backend config, as well as the seal secret, right? Again, we have also defined the service over here, which is again of type cluster IP. If you want, I can also show you the Docker file for this. Okay, let me close all of this. You go to the server. In here, you can see the Docker file. Here also, I have used multi-stage Docker files. Over here, you can see it is installing all of the dependencies. And in here, it is copying the node modules. And then we are just adding this particular user. You can skip this part as well, not an issue. And then we have um, executed the server.js. Okay, so this is quite simple and easy to understand. Yeah, so that's all about it. So this was about my Node.js Docker file. Okay, now if I go again, now I think the backend is clear. Now let's try to understand about the stateful sets. So over here, you can see that the API version is app/v1. The kind over here is stateful set because it is a stateful application. And the name over here is what we have defined, then this is spec over here. Now, this is what is very much important. If I go to the Mongo service, you can see I have used a service over here, but the cluster IP is none. Okay, so basically, this is a headless service. If you define the cluster IP as none, this becomes your headless service. And headless service is something that needs to be defined in this particular way in order to access it. Why? Because here, though we have the selector, still we don't have the cluster IP over here. Since we don't have the cluster IP, it is important for our stateful set to know that which service we are using. That is the reason we are passing the name of the Mongo service over here. The replicas are two. Pod management policy is ordered ready, which means that it should uh, create the pods in an ordered manner. Okay. There is another way that is parallel. So if you want the pods to be created parallelly, then you can mention it as parallel. Okay. It depends on the use case, how you want your database to operate, right? So for that matter, we make use of this pod management policy. Then we have got the selectors again, right? And then we have the labels for our template for the pod. Then the same thing for the topology I have mentioned over here. The containers are being defined over here, right? So the container is running at port 27017. And again, we are passing the Mongo secrets over here. Now, this is another secret, seal secret, where we are passing the root password as well as the root username. So both of them are being passed over here to our stateful set pods, right? So this was what you already know. Now the important thing is about the volume claim templates. Over here we have defined the volume claim templates. So volume claim templates will create a persistent volume claim for each of the pods. Okay. And in this case, we have defined the metadata, that is Mongo PVC. And within the spec, we have defined the access modes, the storage class name, as well as the resources that we need. So the first thing is that access modes. So basically, the access mode we have defined here is read write once. Now, what does this actually mean? Okay, so basically, if you see over here, you can see that if this PVC belongs to a particular node, then this PVC will be accessed by the pods belonging to the single node. Okay, so the pods belonging to other nodes won't be able to access this PVC. Okay, so it is mostly dedicated to the single node. This is the PVC for the single node. But in case of read write once pod, the PVC will be accessed by only single pod within the entire cluster. Okay, so no other pod will be able to access this PVC which is being accessed by this particular pod. Okay, so that comes under the read write once pod. Whereas in case of, let's say, read write once, read write many, what happens is, let's say you have two different nodes. Okay, two different nodes, and you have got these pods over here, and the PVC is here, right? So all of these pods will be able to access this PVC if the access mode has been set to read write many. They will be able to read write across multiple pods within the cluster. Okay, so this is how the PVC works with the access modes. Okay, then we have got this storage class. So we have defined the storage class over here. Okay, so this is the storage class. So for those who don't know anything about storage class, you can just go and read it from here. Okay, so basically, storage class is a way of administrators. It provides a way to describe the classes of storage that they offer. Okay, so different classes might map to quality of service levels or to backup policies, to arbitrary policies determined by the cluster administrator. So itself is unopinionated about what classes represent. Okay, so storage class objects are something which contains the fields like provisioner, parameters, and reclaim policy, which are used when the persistent volume belonging to the class needs to be dynamically provisioned to satisfy a persistent volume claim. So this is what we are doing in our case as well. So what are we doing is we are dynamically creating the, so let's say this is our storage class. Okay. So what are we doing is we are defining the pods, and within that itself we are defining the PVCs. Sorry, PVCs don't belong to the pods. So this is a pod. Now this is the VPC attached to that pod. Okay. Now if I create the PVC, sorry, I'm really sorry. It is PVC and not VPC. Okay, so this is PVC, that is persistent volume claim. So what I have done is I have defined my stateful set. I have defined the pods template, and I've also defined the PVC template, that is volume claim template. Okay. Now once I apply the changes, this PVC will be created, okay, which will be creating my PV dynamically. Okay, so it's not that I have already created the PV, and it's not like that I have already created a PV and then I am creating the persistent volume claims. This was the flow that we used to do traditionally, right? That we used to create the storage class, then we are defining the persistent volume, and then we are creating the persistent volume claim, then we are using it in our pods, right? But when we dynamically create these persistent volumes, we define the storage class, we define the persistent volume claims, and when we apply the persistent volume claims, this persistent volume gets created dynamically. Okay, so this is how we are going to implement in our project. Now let's try to understand what have we defined inside our storage class. So basically storage class defines like what all things are we going to use on our cluster level. So over here you can see this is the provisioner that we want to use, that is the ebscsi.aws.com, because we want to create these PVCs using the EBS. Okay, so then we have the parameters of type GP3. Then we have got volume binding modes, that is wait for first customer. Now what does this mean? So there are two volume binding modes as well. Okay. So there are two volume binding modes. First one is immediate. Second one is about wait for first customer. And here the customer is nothing but your pod. Okay. So what happens in case of immediate? In case of immediate, whenever you create the PVC, in this case, whenever you create the PVC, your PV will be created, irrespective whether this PVC is attached or is actually being used by a pod or not. Let's close this, okay? So in case of immediate, it won't check if this PVC is being used by a certain pod, okay? It won't check. It will just create the persistent volume as soon as the PVC is being created, okay? In case of wait for first customer, what will happen is, even if you have PVC already created, but it is not being utilized by any pod, then in that case, PV won't be created in case of dynamic provision. Okay. So unless and until, so once the pod is being using this persistent volume claim, it will create your persistent volumes. Okay. So this will how the flow go in case of these two volume binding modes, right? Again, we have got the reclaim policy, that is retain. So basically, the reclaim policy is retain. Now, what does this mean? It means that if I set it to retain, the PV will be retained. It won't be deleted if the PVC is deleted. Okay. So if I consider, there are two types of reclaim policy, retain, and the second is about delete. Okay. Now, if this is my PVC, okay, and then there is PV, right? So if I set the reclaim policy to delete, and if I delete this PVC, okay, if I delete it, PV will also be deleted in case of delete. But in case of retain, if I delete the PVC, still the PV will be retained and it will be in a released state. Okay. So this is what is the difference between these two reclaim policies. Okay. So this was all about it. Then the most important part is about Ingress. Okay. So in this particular project, we are going to implement AWS Ingress controller. So you already know that Ingress is something that just defines. It's just a config file. It doesn't actually do anything. You need this controller in order to execute your Ingress. Okay. So just writing the Ingress file won't help. You will have to configure or deploy the controller on your EKS cluster. So that's why we have defined this over here. But we will also be implementing the controller. I will be showing it to you. Okay. So over here, we have simply defined the version, the kind as Ingress, then the metadata over here is app Ingress, and the annotations. Now these annotations are very, very important. Over here, we are making use of alb.ingress.kubernetes.io/scheme. So this is about internet facing. So we want the load balancer to be internet facing and not internal. So for that, we have defined this setting over here. So these are the settings for our Ingress controller. And over here, the load balancer name is something that we have defined over here. Then the target type. Now there are two types of target types. You can say one as IP and the other one is based on the instance, right? So over here we are going to go with the IP. I had written one LinkedIn post where I had defined the difference between the IP target type as well as the instance target type. So there are few differences. You can go through that in order to understand it, okay? Now we have got ALB ingress. Now these are the health check settings. So these are the basic ones. You can modify it as per your needs, as per your application needs, okay? And this is very, very important. Why? Because we are going to implement SSL in this, right? We want our load balancer, right, to have this kind of an certificate with the help of which I will be able to access my application using HTTPS and not just HTTP. So for that, I have used this particular annotation. Again, I have also passed the certificate that I am going to use. So for this, I will first need to create the certificate from the ACM and then add this particular ARN over here. Okay, so this is very much required, right? And this will be changing every time. So this is not a permanent thing, okay? It will keep changing if you create another certificate for it, right? The next thing is we have defined the ingress class. Now this is very much important where we have defined the paths, right? So over here you must be saying what is this? So this is my domain name that I'm going to use for the hosting purpose, right? For my application. So for that I have defined the host over here and I have defined the path. Now again I am implementing the path-based routing for which Ingress is very much famous, right? So if someone hits at this particular path, he should be redirected to this particular service that is front-end service and the port should be this. This is what I am asking my users to do. If they want to access slash backend service, I'll just ask them to go to this particular path of slash API at this particular port of 5000. Okay, so this is how I have defined ingress over here. So this is quite simple and easy to understand. Okay, so I hope this was very much clear. Now we are going to actually implement this project. Now till now, everything was what I explained about the manifest files, the applications that are we are going to deploy, and everything, right? Also, I would like to define the CI YAML. Okay, so basically, we are going to implement uh, this CI pipeline for building and pushing the Docker images to my Docker hub. Okay. So for that, I have written this particular YAML file. So things are repetitive, but we'll try to understand how I have written it. Okay. So the first thing is about the front end. So I hope you all know how to write the GitHub actions first of all. So in here I have defined the name. Okay. So on pushing the changes to the branch main, only then this particular pipeline will run. Okay, so this is the usual workflow even in the production environments because they don't want to entertain uh, certain production level pipelines to be managed by multiple branches. It is only related to the main branch. So once you merge the changes to the main branch, then only this pipeline will execute. So we have got front-end image as vanderblog hyphen frontend and the backend image as this. Okay. So within the jobs, here we define the actual steps. Okay. So the changes. So whenever there is a change within our front end as well as back end, then only these pipelines should run because these pipelines are building the Docker images and Docker images are built from the application. So if there are changes inside the application, then only these pipelines will or these particular jobs will run. Okay. So this is what I want and this is what I have defined over here. Okay. And I have defined the detect changed paths. Okay. And it runs on Ubuntu. The outputs are defined over here. The steps, the first step is to check out the code. The second step is to filter out. Okay. So if there are changes in case in the front end, then only front end job will run. If there are changes in the server folder, then only the front end, only the uh, backend job will run. Okay. So over here we have got our front end job. Okay. Now how have we defined this? So the first thing is about front end, test, build and push. So actually we are not testing anything, but generally these things are tested as well, right? So it is running on this particular image of Ubuntu latest. Then we have got needs as these changes. So it will need the changes job in order to detect the changes. Once these things are detected, then only it should, if it is true, then only this pipeline should execute. Only this job should execute. So then we have got the defaults. So it should run inside the working directory front end. Then we have got the steps. So first it is going to check out your code. It is then going to um, log into your Docker Hub. So for logging, you are using this particular image. Okay. And these tokens are being defined within the secret of our repository. I can show you that as well. Okay. So basically, go to your repository, go to the settings. Inside the secrets and variables, you will find action. And within that, you will find this option of new repository secret. You can just go over here, define the name, let's say Docker username, add the Docker username over here and create and click on add secret. Your work will be done. Okay. So this is what we have done for Docker username as well as Docker token. Fine. Now we want to find the latest image. Now, if I go inside my Docker Hub repository, if I go inside the front end, you can see this is the latest tag that I have got, that is V1. So this code is going to fetch the latest tag. So it will fetch its V1. It will understand that the latest is V1. Okay. If it has got nothing, then it will set the next tag as V1. If it is empty, right? Else it is going to just extract the version number that is 1 and then it will add 1 to it and give the next tag. So the next tag will be V2 and that is something that we are storing inside the GitHub output. Okay, once we do that, we'll be building the image, right? So for building this, we have got this particular image docker build push action. So what this will do is it will create it with the, so with this you get the output value. So over here you can see we have mentioned next tag is equal to the v2, right? So what it will do is it will store inside the output. So steps dot get tag dot output is nothing but the GitHub output path, and within this we have got this next tag. We are just adding the next tag over here. So what it will do is it will consider the context of front end. Within that, the file which I want to use for creation of this Docker image, and the push, if it is true, then you will be building and pushing this particular Docker image. Okay. Then after that, you will be outputting image URI. So this will be the image URI over here. Okay. And then the updating the KTS manifest file. So now it is important that you build a new image, you push it to the Docker file, to the Docker hub. But now it is important that you also update your Kubernetes manifest, right? Because the image that you have defined in here will be referred by the ArgoCD, right? So what you are doing is you are updating your Kubernetes manifest. So within that, what you are doing, you are running this particular command where you are just replacing the previous tag with a new tag, okay, for our image, okay. And then we are just committing the changes to the this particular repository of Vanderblock. And similarly, these exact steps are being followed here for the backend as well. You can go through it and try to understand it. Okay, you will be able to understand it very well. Okay, so this was all about our repository understanding as to how I have written the Kubernetes manifest, how I have written the ci.yaml file. Okay, how is it going to update our Kubernetes manifest? So till now, I hope everything is clear. Okay, because if these things are clear, you will be easily able to understand the entire thing that is happening in this particular project. Okay, now let's get started with the demo. Now this is going to be very, very interesting, and I want all of you to watch this video till the end if you really want to benefit from it. Okay, so stay tuned. So basically in this video, we are going to define the readme.md file. Okay, so in here I have written all the required steps that needs to be followed. So you can also refer to this particular file in order to execute all of these steps in your own environment as well. Okay, so don't worry. Okay, you can just follow along with me as well. It will be very much helpful to you. Okay, so now the foremost thing that we are going to do is set up an EKS cluster. Okay, but before that, what I would like to do is I would first create a Route 53. Now, we are going to implement a Route 53, which I already explained you guys, right? So what we are going to do is I have already created a domain. So on Hostinger, you can see that I have created this domain name that is vanderblock.online. So if I go inside of this, can see all of the details available over here. Okay, so I'm going to just create a Route 53, a hosted zone for this particular domain. Okay, so I'll just go and create a hosted zone configuration. Okay, so I'll just mention it as vendor blog dot online. Okay, so this hosted zone is used to host a vendor blog application, right? So once I mention it, I'm just going to create a hosted zone. So now you can see that my hosted zone has been created over here. And in this case, you can just see that for the vendorblog.online, I have got NS, right? That is the name servers. So these are the values. Okay. So the foremost thing that you have to do is just go to your hosted website, hosting website, okay, and just go to the DNS or name servers that are being used by your um, domain, right? So over here you can see that these are the DNS names which are default. Now what I want to do is I want to use these particular name servers for my uh, domain. So what I'll do is I'll go to change name servers. Okay, one by one I'm going to copy all of these values to it. Okay, so this is the new name server for me. So all of these uh, name servers have been added to it. Okay, so I have added all of these name servers. Okay, and you can see that you can't see the DNS records now. Okay, so these names, so this particular domain is now going to use these name servers. Okay, so the reason for doing this is because I want to make use of Route 53 first of all. Second thing to route, okay. Second thing is that I want to add a certificate manager which belongs to AWS, that is ACM. Okay, so I want to make use of this certificate manager for my website. So what I'll do is I'll just create a new request. So this will be a public certificate. The next thing is fully qualified domain name will be vendorblog.online. Okay, so this domain is something that I have already bought from the hostinger. You can buy it from any uh, legal website, okay, through which you can use it for your purposes. So keeping the rest of the things, I'm just going to request it. So once you have created a request, you can see within the domains, you will see something. So basically, this domain is something that you want to be managed by the Route 53. So you will create a record in Route 53. Okay, and create records. If you go back over here and just refresh it, then you will be able to see this. Over here, you can see this record for your certificate has been created over here. Okay, so over here you can see it is in the pending validation. So it will take some time to load these DNS name servers and then use and to validate this particular certificate. So that is the reason I did it first, so that even if it takes time, um, it will be okay for us, right? So it is going to do its work for us. Now, the most important thing is to get the ARN. So this is the certificate that I want to use. So what I'll do is I'll go to my Kubernetes manifest, especially to the ingress.yaml, and I'll try to edit this. So what I'll do is I'll just edit this certificate, okay, and commit the changes. So this is my new certificate that I'm going to use for my Ingress, right? So this is what I wanted to do. Now, once this is done, let's go to our README again. So where is it? Yeah, it's here, right? So basically our front end will be running at port 80, the back end will be running at port 5000, and the MongoDB will be running at port 27017. Okay. Now, the most important thing is to set up an EKS on AWS. So for that, what we'll do is we are going to make use of EKS CTL. Right, I already mentioned it. You can also create a separate pipeline, infra pipeline to set up the Kubernetes cluster. So for that, I can refer the video that I had already created for the creation of EKS cluster using Terraform as well. So I'll add it in the description. You can just go through that, or you can prepare that one pipeline for your infra, and then a separate pipeline you can use for the application deployment. So this is what you can achieve. Now the most important thing now is to install the EKS CTL. So basically I'm going to make use of Cloud Shell. Okay, Cloud Shell, which belongs to the um, AWS, right? So what I'll do is if I do EKS CTL, sorry, I'm really sorry, you can see that this is not available over here. So for that matter, I'll first need to install it. So I'll just paste it out. Okay. And now if I do EKS-CTL, it is now going to show all of these, right? Which means it has got installed. Fine. Now once this is installed, what you can do is you can create the cluster. Okay. So what you can do is you can just clone this particular repository in the Cloud Shell. Git clone. If I go inside of this, you can see EKS config.yaml file over here. I am going to use this particular YAML file to create the EKS cluster. So over here we have got the command, that is EKS create. Let me just open it separately. Yeah. So over here you can see this is the command. I'll just copy this out, paste it out. Okay. So now with the help of this particular configuration file, we are going to create the EKS cluster. Now this again is going to take a lot of time. Okay. So till that, what we can do is we can open another Cloud Shell. Okay. And do the other installations. So basically we are going to install Helm. So I'll just use this. So with these commands, I'll be able to install Helm. Okay. Now if I do Helm version, you can see Helm has been installed. Okay. One more thing, I will also be installing kubectl. Okay. So for using the sealed secrets controller, you will require this command line kubectl as well. Okay. So for that matter, you will have to install kubectl as well. So you can see this is the version and it has been installed over here. And this one, so you must have noticed that whenever we make use of an EKS CTL, it works with CloudFormation. So over here, if you check, it is waiting for CloudFormation stack, which means that if you go on your account and search for CF, that is CloudFormation, you can see that this stack has been created, the CloudFormation stack. Okay, and it is in progress. So within the events, you will be able to see all of the events. So basically, a separate VPC is been created for our EKS cluster, right? So everything has been created from scratch, right? Internet Gateway, NAT, that is NAT IP, then also the all of those subnets, private route tables, all the networking components are being created uh, with this particular cloud formation stack, right? So internally, EKS-CTL will work with the cloud formation. Okay, so it is currently work in progress. Okay, so the next thing that we can do is we can create the policy. So let me check if this AWS load balancer control IAM policy has been created or not, because I had created it previously as well. So let me check it. Okay. So basically, if you go to impolicy.json, so yeah, if you just curl it, you will be able to understand what I am talking about. So this is the policy. So basically, this is what the policy is all about, and it is for the load balancer controller. So if we want to implement it, we will need this particular policy being attached to this particular service account, which we'll be using in order to create the load balancer controller. So for that matter, we will have to create this policy. So let me just go and create this policy. So IAM, if I go inside the policy, yes, so this policy is already created. You can see that it has got all the permissions that are required for creation of the load balancer target groups and all of the things related to VPCs and network interfaces and security groups. Also for the WAF as well, the things are being mentioned over here, right? So ACM, so it is able to access the certificates with the help of this ACM, right? IAM list server certificates, get server certificates, all of these things are important. Also the authorized security group Ingress. So it is going to work with Ingress, right? So for that matter, you need this permission as well. So all of these things are required for our AWS controller, right? AWS load balancer controller. So the first thing that we are going to do is we are going to create a service account once the cluster has been created. So the cluster creation is still in progress. So we'll have to wait until the cluster is being uh, created. Okay. So I'll be back once the cluster has been created. Okay. So now you can see that our EKS cluster is ready. So let's go to our EKS cluster and check what all things are created. Okay. So if I go to this particular cluster, you can see the version is 1.35 over here. Okay. You can see the API server endpoint, the certificate authority, OpenID Connect since we have enabled it, right? OIDC, right? So that's why it has been provided with a URL. Then also we have got cluster IAM role over here. Then the cluster ARN is also provided, right? So within the resources, you can see there are different pods running, right? So that is AWS Node and Core DNS, Kube Proxy, Metric Server, right? Replica sets only for the Core DNS as well as Metric Server, right? Then do we have stateful sets? No, we don't. So only few resources have been created. So within the compute, you can see that we have got two different nodes of type t2.medium, right? So this is the name of our node group, pandablog hyphen node hyphen group. And this is the name of my node group, right? So it is in the active state currently. So we are not using any Fargate profile over here. So it's 0. Okay. Then we have the networking part. You can see a separate VPC has been created. So this is the range. These are the subnets that are being created. Then the cluster security group and everything. Okay. So if you go to the instances and I refresh it, you can see that two different nodes have been created over here, right? And you can see that each one of them is in a different availability zone, right? So one is an AP South 1A AP South and the other one is an AP South 1B, right? So now we can proceed further to apply the changes to your cluster. Okay, so you can see that this particular policy was already created, right? This one, the AWS load balancer control IAM policy. So what I'll do is I'll just copy this. So the only difference that we have, the change that we have to make is with the account ID. So it will be different for each one of us. So let me just open the notepad for me now. Just try to open it here. Okay, I'll be pasting it out and I will be modifying the account ID over here. So let's go copy the account ID and just paste it over here. Okay, now copy the entire thing. Okay, and just go to the Cloud Shell and paste it over here. Okay, enter. So it is going to create a service account for you. Okay, I will be teaching service account to all of you in the coming lectures, but service account is nothing but a user at the level of Kubernetes. Just understand it that way for temporary basis. Okay, so service account has got its own role to play. Okay, so create an IAM role for the service account. So this service account is going to create a role for us. So if I go again in the IAM roles and if I add here service account, no, I don't think so. The name is, what is the name? Let me check. the name is this, right? So I will be just searching. Okay, just refresh it. So over here you can see this is the IAM service role that got created. Okay, and this is the controller policy, right? So with the help of service account, this role was created. Okay, so this is the required stuff. So now your service account has been created. Okay, once it is created, you are now ready to install the AWS load balancer controller, but you can also install the sealed secrets controller as well. Okay, so since it's the sequence, I'll just create it. Okay, so let's go over here. So I have already installed the sealed secrets controller. So how to check it? Using kubectl. So kubectl is already installed by default in the Cloud Shell, so you don't need to install it. So kubectl get deploy -n kube system. So kube system is a namespace which is already present. Okay, and here you can see seal secrets controller. Okay, so it got successfully installed on your cluster. Now the next thing that you need to do is you need to install AWS load balancer controller, which will be our Ingress controller. So it is important to, okay, install it. So over here you can see we are installing this particular load balancer, and the cluster name is this that we are passing. The service account, we are not going to create any service account. Why? Because we already have created, and this is what we are passing over here. So, and this is the version of it. So I'll just copy it out. Okay, and then just paste, and it is going to install. So now over here you can see within the kube system namespace this particular controller has been created. So just um, execute the same command that you had executed earlier. So over here you can see this controller has been uh, there, but still the pods, yeah, now the pods are ready. Okay, it's up and running. Okay, now since we are not going to directly or manually apply the changes, we are going to make use of ArgoCD for the deployment purpose. So for that, we'll first create an ArgoCD namespace. Okay, and then we are going to apply the changes. Okay, so we are going to again install ArgoCD on our cluster. So all of these, there are CRDs, there are role bind RBACs, the cluster role binding, then service accounts. All of these things are getting installed on my cluster. Okay, so if I do kubectl get all -n argo cd You can see all of these resources related to Argo CD being deployed, though few of them are not yet ready. But if I execute this command once again, I think, yeah, so still this Argo CD server is yet to come up. So let's wait for it. kubectl get pods -w. Sorry, I need to mention the namespace as well, -n Argo CD. So now you can see the Argo CD server is also up and running. Okay. Okay, cool. Now the next thing is that if you if you get the service, so let's try to find the service of kubectl get svc -n argo cd. So over here you can see that all of the services are of type cluster IP with the cluster IP addresses right here. Okay. So it is important that the Argo CD server, if we want to access it, it has to be of type load balancer. So for that matter, what we are doing is we are just patching, that is, we are editing it and making it so for the Argo CD server only, since we want to access it. So I'll just make it of type load balancer. So it is now patched, and now if I again go with get svc -n argo cd, you can see that it has been changed to load balancer, and this is the new load balancer DNS that I can access. Okay, so if I go over here and try to access it, continue to the site. Okay, so it is not able to access it. First of all, I will try to get the password first. Okay, so we need the password in order to log in here. So it will, I don't know why it's not working. It should be working, right? Oops, sorry, I copied something else. Just give me a sec, okay? So now you just go to advanced and try to access it from here. Okay, so this is your Argo CD dashboard, and in here the username will always be admin, and the password that you pass over here is of what you get when you, yes, so this is the password that you get. Okay, copy it out and paste it right here. Okay, and sign in. So now you are inside your Argo CD. Okay, and in order to deploy, you will just go and create the application. Okay, but before that, the most important thing is that our certificate is issued. Congratulations to all of you that our certificate has been issued, right? The next important thing that we need to implement is that we first need to seal the secrets, right? And also we need to add this particular role to our um, node instance role. Okay, so I'll just copy this, paste it over here. why is this required? Basically, it is required for the EBS volume. So I mentioned in the storage class, right? As the provisioner, I had used EBS. So for that, this particular node should have that uh, permissions to work with the CSI driver. So for that matter, we need to add this particular policy to this role of our node instance. So let me check what is the name of the role that has been attached to our instances. So let's go over here. If I go inside the security, this is the name of my role. I'll just copy it, okay? And I'll paste it over here. Okay. Now this should add. I'm pasting it over here, enter. Okay. Now if I go and check, let me go over here. And if I check the permissions, it should have CSI driver policy. So this is what we have attached to our node group instance, right? So this is done. Okay, let's close this. So very well. Now we are ready to implement the, yes, exactly. So now we are going to add on. We are going to install this add-on of EBS CSI. So just enter it over here. So whenever you see a hyphen K, it is because of the customize. Okay. So they have used customize, okay, in order to configure this particular YAML file. So over here, all of this has been created. Fine. So we are now ready to implement the EBS as well. Okay. Now the most important thing is to create the secret files, right? So you need to create this secret file manually. Okay. So if I go inside this Kubernetes, I will first try to remove the existing ones, that is rm mongo sealed secret.yaml. I'm going to remove it. I'm also going to remove the backend hyphen sealed secret. So these two are something that I'm going to create fresh. Why? Because every time the controller uh, key will be different, right? So in order to use the current cluster, we are going to create it once again. So just copy this for this current cluster, we have to configure these sealed secret files. So just execute these commands. Okay. So this is something that you get. Okay. You can also copy this directly from here. Okay. Just do one thing. Copy this. Go to your Kubernetes manifest. Go to your Mongo secret. It's Mongo, right? Yes. So just replace it with that. Okay. You can keep these things same, right? Just commit the changes and you are done. Okay. So you are done with the MongoDB sealed secrets. Now similarly, you can go for the backend as well. Enter, paste, and now you get another set of secrets file. Just copy this. Again, go to your sealed secret. Just edit this file, update this file, commit the changes, and you are done. Okay. So this approach is generally used for the ArgoCD. Okay, since it has got Git as its only source of truth. So now you have made the desired changes. Now the next thing is that you have also worked with this particular stuff, right? Now the only thing that has been left is to deploy the application using ArgoCD, right? So how will you do that? Just go to your ArgoCD, go to this vendor blog first, okay? Just copy. See, already I have pushed. I don't need to execute the CI pipeline now. Okay, why? Because I have already executed it, and you can see that within the Docker Hub, I already have got these uh, images already created. So I don't need to create the one more image. Okay, so all the updated images have been created over here, have been pushed already. So V1 is here. And if I go to the front end, you can see V1 has been already mentioned here. So we don't need to currently uh, go for the mm, running the CI pipeline, but while you do it, you will be executing the CI pipeline. Okay, so that it will push the image onto your repository. And once this is done, you are now ready to go and create an application on ArgoCD. Okay, so the application name is like vendor blog, right? The project name is default. Okay, keep the sync policy as manual as of now. Then the repository URL is important. So I'll just copy the URL from here. Okay, copied. The path. Now the path is very much crucial where you have got your manifest files. So I'll just copy this out, right? Kubernetes manifest is where we have our manifest files. Then the cluster URL is this. The namespace is default where I'm going to push the changes. Okay, you can also create a specific namespace and accordingly you can uh, push the changes. So I'll be creating, and you can see this over here. Since it is manual, I'll have to click on the sync and then synchronize. And then it is going to pull all of the changes from your GitHub. Okay. And now if I go onto my cluster, okay, and if I check for kubectl get all, you will see the backend, the front end, the Mongo, all of these have been created over here. Okay, so and also the sequence in which these stateful pods will be created is first it will be creating Mongo 0 and then Mongo 1. Okay, so it goes in sequence because we have defined the pod management policy as ordered ready. Right now if I do get all of them are running. Okay, now if I go and try to access my application on this particular host, it should be showing me. Okay, there is some problem it seems. Let's wait for it. It's still configuring the Mongo. Okay, it's still in the configuration stage. So now you can see that Mongo is also up and running and everything is in place. Let's try to access it once again. Vendor blog. Yeah, the most important thing now. I didn't add the load balancer DNS over here. So this is something that I'll have to do first. So go to create record, right? So over here, I won't be adding any subdomain over here. Click on or enable the alias. Go to the application and classic load balancer. Okay. And the region over here is Mumbai. And the load balancer is Vanderblog Ingress, right? So I'm gonna select this and yeah, and just create records. So this is the A type record. And now if I go with Vanderblog dot online, okay, it might take some time, okay. Yes, so this is our website which is up and running now. Now I can also create a blog over here. Let's say Japan is my destination. Let's say author is Prem and let me find an image for Japan. Okay, so I like this one. So I'll just copy the image address and I'll go over here and paste it. Story is Japan is very good to visit during spring season. So now you can see you have published your first blog over here. So this is how you can publish it, you can read it, and you can explore this. Okay, so this is a simple website, but the architecture behind this is very, very complex and it is production graded stuff. So I hope this video was very much helpful to all of you. I have tried my level best to explain as much as I can. It was very vast video, and if you are still here uh, watching this video, I bet you come among the top 1% people and you deserve to be hired in a good company. And not just that, you have very good amount of patience which will take you very, very ahead in your life. So thank you so much for watching this video till here and being patient with me. So I hope this really helped you, and also let me know in the comment section if you have any doubts or any questions. You can definitely ask me. I'll try my level best to answer as much as possible. Okay, so first of all, thank you so much, and all the very best to you. Thank you.